Welcome back. Hardware development could be tedious, much more so than software development. Imagine if any mistake in your code would cost you an actual board. To address that issue, the hardware industry has invented field programmable gate arrays. Yepremyan here from AMD Armenia is here to tell us about the FPGA technology and how it works. Leah, I welcome you on stage.
Hello. Today I will present FPGA basic principles and introduction to how it works. Here we will cover the basic principles of FPGA. First of all, we will take the overview, the basic architecture of FPGA. The purpose of this presentation is to present the FPGA design process and the tools which are using to program the FPGA. In addition to that, we will also discuss the programming languages which used in the FPGA and how to create your first code. I will also provide one practical example and dive into FPGA optimization. So let's start. My name is Leah. I'm working in AMD already 2 years. I am mainly specialized in FPGA implementation. Besides this, I have worked in ASIC architecture more than 9 years. So I can say that I have a complete notion between FPGA and ASIC architecture differences. The company where I worked, Xilinx, was a semiconductor company that primarily supplied programmable logic devices, and the company was known for investing the first variable failed programmable gate arrays and created the first manufactured version. Xilinx was founded in 1984. In 2020, on February 14, 2020, AMD acquired Xilinx in a full stock market. What about AMD? Advanced Micro Devices develop computer processes and related technologies for business as consumer use. AMD's main products includes processor, microprocessor, motherboards, personal computers, workstation, FPGAs, embedded systems. So here is the introduction through which we will go today. The first one, we talk about what is an FPGA. Then how FPGA is used and how can we program an FPGA. Later I will go into application and architecture of FPGA, introduce one example, how to designing and coding in FPGA, and in the final we see where are we going with FPGAs. Before starting, let's do differentiation between software and hardware. Software, as we all know, is a code or program and application that you run on a physical device. Hardware refers to the physical components of a computer or machine that you can see or touch. It can be RAMs, integrated circuits, flash memories, etc. The specific hardware can be configured by specific software to implement some task. So let's discuss in terms of everything in terms of hardware. Hardware is an integrated circuit which consists of RAMs, flash memories, integrated circuit, serial receiver, transceivers, etc. Each and other elements. Each element can be classified can be composed with digital logic circuits. Digital logic circuits by itself classified as combinational circuits and sequential circuits. Combinational circuits as thus whose output solely depends on their inputs. The example of combinational circuits can be adders, subtractors, converters, encoders, decoders. Sequential circuits, on the other hand, as that was built using the combinational circuits and flash memory called flip-flops. The output of sequential circuits depends on their previous and input states. Examples of sequential circuits are flip-flops, state machine, register, etc. So FPGA by itself considered as a hardware. So let's talk about FPGA. What is a FPGA? Field programmable gate arrays are prefabricated silicon devices that can be electrically programmed to become any kind of digital circuits or system. The term field programmable indicate that FPGAs are adjustable and not hardware like any other ICs. The fundamental functionality of FPGAs built on their adaptive hardware, which is give us ability to modify it after manufacture. Arrays of hardware block is configurable, can be connected as needed, provided a highly efficient domain-specific architecture, which is widely used in embedded design automation industry. Here is the picture of one FPGA simple example, and the left side picture is shown the FPGA as an internal block. We can say that FPGA is a unique combination of soft and hardened IP. IP cores support design reuse, so electronic designers and engineers use them to implement a certain task. It provides the ability to widely use of any other application. So there are three main types of IP cores: soft IP cores, firm IP cores, and hard IP cores. Hard IP cores is our physical manifestation of IP design. They cannot be portable or flexible, unlike two other type of IPs. They have its fixed location in FPGA and cannot be ported or programmed to work with other modules. The firm IP can be configured and modified to work in different applications. Compared to hard IP, firm IP provides greater flexibility because it gives us a possibility to place the module inside the FPGA and interconnect it with other modules. The soft IP core is the most flexible type of IPs because they provide us the ability to map the process with a wide range of applications. Besides this, with IP cores, licensee get the source code with license, which the designer can modify to work with different application in different process. Besides this, IP cores can be used to work with different type of FPGAs. It's not FPGA defended. So I have also bring the equivalence between soft cores and between each core with soft components. So we can say that soft IP is equivalence in source code in software sphere. Hard firm IPs are object library, and hard IPs executable modules correspondingly. FPGA require configuration, so each logic block and interconnect know which role they should play during implementation. Arrays of hardware blocks are configurable, can be connected as needed, so it gives us the ability to change the module and work it with different application. The software, the FPGA use the software to configure it. So the main languages which are described, which can use to describe the design are VHDL and Verilog or software Verilog. Programming languages like C or C++, whose modified version can be used to implement or program microcontrollers or microprocessor, cannot change the logic of FPGA. They only can send send the instruction to FPGAs. We can say that the FPGA here is the picture, simple picture of FPGA. It consists three major blocks: configurable logic blocks, input-output configurable blocks, and switching matrices or interconnects wires. Here is shown highlighted each block. Let's discuss each block separately. Configurable logic blocks are the basic cells of the FPGA. This component is responsible for implementing core logic function. These cells also implement the storage functionality of FPGAs. They consist of different types of elements. For example, lookup tables, flip-flops, full adders, multiplexer. Lookup table-based programmable blocks can be used both for functionality and both for logic and storage functionalities. Configurable logic blocks, as I said, can do many different modules and function. The main block is a lookup table, which is responsible for logic. The lookup table stores the combination of input, which they store and reproduce in their output. So they can be configured in the term of our design. From the superficial point of view, we can imagine that the FPGA consists of the AND gates, OR gates, or other element, but actually there aren't exits physically in FPGA. Logic blocks are configured so that behave like this. To achieve this process, we are using lookup tables. Lookup tables on FPGA hold truth custom tables, which is loaded when our FPGA is powered up. We can even imagine that our lookup table is a piece of RAM, which is loaded whenever we power up our chip. There are also other elements which you working with lookup tables in configurable logic blocks. The next one is input-output blocks. Input-output blocks are using to interconnect outside world with internal side of FPGAs. I/O pads are using to connect the outside peripherals to access the function of FPGAs. I/O pads and surround circuitry together form an input-output cells. Input-output cells are very important in designing FPGA because there is a large variety of supporting standard voltage and reference standards. And these I/O cells are consumed very large portion of FPGA, approximately 14% of whole area of FPGA. And its implementation very challengeable because unlike lookup tables that can implement a certain logic, input-output cells can supply only one standard, which is chosen with the designer. If our FPGA supported more standards, it will increase the required area used for I/O cells. Also, it will increase the capacitance between pins, which will limit performance. The next one is switching matrices or interconnection wires. Switching matrices are used for connection between I/O logics and I/O cells inside the FPGA. They are connecting short and long wires inside the FPGA. There are also used transistors to turn on and off the connection between desired layers. Programming interconnecting routing are used to connect input-output cells with logic cells. There are used three types of cells to provide this connection. There are three-state buffers, multiplexer, and pass transistors. Pass transistors and multiplexer are used for inside the logic cluster to connect logic blocks together, while three-state buffers are using for global routing. For global routing are used different types of techniques. One can be cellular, pipeline, or island-based. As we already know, what is the FPGA structure? So we can say that FPGA can solve any problem which is computable. It is trivially proven by the fact that FPGA can implement a task of soft microprocessor. Their advantages lies in that they are significantly faster for some application because of their parallel nature and optimally use the number of gates. FPGAs originally began as a competitor of CPLDs, complex programmable logic devices, to implement glue logic for printed board. As their capacitance, size, and speed decreases, they took over advanced functions. FPGAs using software. We can configure FPGAs. This software generally provided by the FPGA suppliers. And using this, we are compiling our FPGA. First, we are compiling by synthesizing and placing and routing all cells, logic blocks to implement for target FPGA. FPGAs are used to design design-specific integrated circuit in ASICs. First, you design your code, your circuit, and then you check the prototype using the FPGA. Once, in this case, errors can be corrected. Once our prototype working as expected, we can manufacture our design, our circuit, based on that FPGAs. It will save time because manufacturing integrated circuits are very difficult and time-consuming process, and it will save money because one FPGA can be used for many iterations of certain tasks. Besides this, in this context, it is worth mentioning that today's modern TPUs, tensor processor units, and cryptocurrency miners are fabricated using FPGAs because they are first designed with FPGAs and then manufacturing. Another trend of using FPGAs is random acceleration. Once can use the FPGA to accelerate certain part of the algorithm, and they share the competition between FPGAs and main processor. Furthermore, FPGAs are used in projects where hardware configuration is subject to change, and the circuit can be adjusted to these changes is called for. For example, if hardware changed its suppliers and our hardware don't have required interface, FPGAs in this case can be a natural choice. Besides this, FPGAs can be used in many different spheres when they are play primary role and very important role. As I have promised, here is the one example of designing and coding. First phase of hardware design, rather it ASIC or FPGAs, starting with designing and verifying the whole process on the paper before starting actual coding. In this process, in this phase, the whole design broken down into different sub-modules. In our example, we have 1-bit full adder, which is broken down into 2 modules, 2 half adders. When the design creation process is completed, we can write the code. The code is, as we see and say, consists of the 2 sub-modules of half adders. When the code is ready, we are reading it into appropriate software. For example, for Xilinx it Vivado, which is help to according our code to create the scheme. This by synthesizing the design. Rather, after that, it is placing and routing the blocks into the target FPGAs, and after the implementation, the tool generates bitstream file. This bitstream file is the when then downloaded into our FPGA board, and FPGA board then ready to implement the current task. For us, it's implementing 1-bit full adders. FPGAs are not new, but are becoming more necessary due to the increase of areas like artificial intelligence. FPGAs, the first commercial use FPGA was invented in 1945 by Xilinx and dominates 16 to 17% of today's market industry. FPGAs are used due to their programmable natures. They are ideal fit for many different markets. They are using in different applications, such as can be aerospace and defenses, medical center, science, video and image processing, wired and wireless communication. Here I have an example of image processing. Image filtering is one useful technique for image processing and computer vision. It uses the FPGA to eliminate the useless details and noises from the image. For this purpose, we are choosing the specific FPGA which have ability and appropriate logic to implement tasks. We can write the algorithm for image processing, write it into FPGAs, and when FPGA implements that task, we can import the blurred image into FPGA and get the fine image from it. Going forward, FPGA market is set to expand. The main CPU manufacturer companies, which is specialized to manufacture standard CPUs, are expanding their product portfolio by acquiring companies which are specialized in FPGAs. For example, 2015, Intel bought Altera, the US-based company which is manufacturing gate programmable arrays. While last year, AMD acquired Xilinx, which is also specialized in FPGAs architecture. Going in this way, the FPGA will be more widely used in networking. Besides programmable logic cells, FPGAs will also contain highly specialized silicon elements that are network elements. They are also going to be manufactured, implemented the network specific FPGAs, which will work with FPGAs with networking. FPGAs will contain also more configurable logic blocks, which will give designers to implement more complex tasks. Besides this, FPGAs will machine learning is moving from GPUs to FPGAs. FPGAs components have been proven that they are flexible, they are power efficient, and faster. They have that components inside the FPGA. So FPGA can be widely used in data center, that is machine learning. And going further, FPGAs may replace the CPUs and GPUs as the main chip in the field of robot research and development in the future. I have tried to cover basic principles of FPGAs. I hope it was interesting for you, and thank you.
Thank you. And for those of you who are on remote, well, it is sad that you didn't arrive in person, but we also accept questions through the Telegram chat. So, any questions now? There would be one from me. What would you suggest as a starting point in development with FPGAs? Maybe a book or an online guide, or what do I start with if I want?
It depends which are you going to do with FPGAs. If you are going to create a design which will work with FPGAs, first FPGAs, for work with FPGAs, we need the knowledge of hardware description language, that is Verilog or VHDL, to describe the design.
I guess it was on one of the slides.
Yes,
right?
yes.
Okay.
While VHDL, you have VHDL knowledge, so you can start to work with software tools to implement, to synthesize, and place this. It depends what are you going to do with FPGAs.
Okay, thank you. The one in front and the one in the back.
Thank you. Are you doing synthesis in Armenian branch?
Yes, we are synthesizing and implementing the
Why
design.
I'm asking? Because we cannot, we have a big Armenian branch, but we cannot use your tool, for example, Vivado, because of location. Why?
Maybe it's depends on our location, where are we, but in our company, as we employees, we have a license to work with Vivado, but it's depends on our country and the policies.
Yeah, but we implement it, we design that, but we cannot use it. It's interesting.
It's the policy of Armenia.
Thank you very much. My name is Andrei from Curator Labs, and my question is there any limitations to FPGA, or we can safely assume that any piece of software can be run on an FPGA?
It depends on the FPGA type, because there are FPGAs which can used for configure some functionalities, and there are EA engine prone FPGAs which contain FPGAs for having artificial intelligence blocks. So it depends which task we are going to do. For now, the area of using FPGAs are growing. As I said, it contains both CPUs and GPUs, and we can have a hybrid of this connection to implement mostly any task.
Hi. From what I heard, on FPGAs, it takes much time to compile and deploy new code. Could you comment on that? And yes, and there is also another question.
You mean the compile time is bigger?
Like hours, yeah, to deploy new FPGA.
It depends on the type of FPGA family, which FPGA you are using, and the size of your design.
Yeah, but what ranges of deployment time could it be? Could it be days or minutes for any type?
For a whole implementation?
Yeah, if you have a new implementation, how much time would it take to deploy it to the board? Like,
it depends on the size of design and the family which are using, because FPGAs have a different families. One can be very faster and have the many elements. If it has a large number of elements, designing and compiling time may increase. But if you're using the small design and small FPGA, it can be hours or minutes even.
okay, so at least minutes to deploy.
Yes.
And do you see FPGAs coming like to our phones, for example, and so we would update hardware as we update software on the phones in the future?
In phones,
Yes,
in phones they are using in cameras.
No.
Yes, currently they are using because many cameras in phones. We have a video. Then we have a processor unit inside the FPGA which capture the video and compile it to work with the display inside our device.
Already on the phones,
yes,
right?
Yes, we have.
But do we ever update these FPGAs like to the new design?
Sorry?
So FPGAs are programmable, but
Yes.
if they're in our phones, are they ever updated to new program?
I guess the question is around like, should we expect like in future some boards which are FPGA based to be updated from the internet?
Yeah, we have. Because FPGAs also provide wireless communication. So they are using even in vehicles to work with other car-to-car or camera with video processor.
I would also like to mention that there was there's a question in front. We need a mic. Right. So what I wanted to mention is during a High Lord Foundation last year, I think, there was a talk by Max Lapshin about designing their own motherboard. And I'd suggest that those of you who are interested in that take a look at that, because there's the recording on YouTube, etc. So they actually went through the process of hardware design and finally got to the ASIC, which was their own motherboard for their own computers, and that saved out them like lots of money. Please, the question.
Can we have some generic solutions for FPGAs not connected with chip? Or
You mean to generate bitstream and import it into FPGAs?
yeah,
It's
not chip specific. Some generic design.
yes, we have. We can have a specific generic design which will work any type of FPGAs. If it's a simple design, for not machine learning, because for machine learning the tasks, we are using the other FPGAs, which are only using for this task. But if you have a generic design, for example, our design, which is the example and very small, it will work with any type of FPGAs.
And when you decided to compare your tool, you need to choose some complex design, yes?
For
other, for example, you decided to compare your tool with other competitors, and in that time you need to choose some complex design, but it's chip specific. And in that way, what are you doing?
For testing our FPGA board family, we are using stress tests, which can be the big test design to implement in our FPGA. So we see how FPGA behave in that case. But yes, between the differences in FPGA families, because there are nodes changing, and if from one family moving to another family, the configurable logic blocks are changed. Their placement are changed and their working structure are changed. In this case, need to do porting the design. So it will do the hardware designer, who is very know the hardware description language, because the first phase of designing is starting with hardware description language. So the hardware description language then we read in our FPGA. Hardware description language doesn't require any limitation, because it's RTL code and it works with every synthesis tool. But once we have synthesis, this synthesized design, and we want to going to implementation of the design, and this synthesized design is the one choice we have. Yes, it's depend of the type of FPGAs, and we can do the porting by the hand or by some Tcl scripts or Python scripts to implement our design to be corresponding to the new type of FPGA. But for Verilog, for VHDL, it's common. Verilog can be imported in any kind of FPGA.
Well, I guess we have 3 nominees for the best question. So, which one do you choose?
Actually, difficult question. The most difficult. So I think the best question will be for the best question will be the person who gives many questions. I think.
Okay, thank you. Thank you very much.
Thank you.